Thank you. So good evening to everyone. Tonight, Dr. Peter Schubert is our speaker. Dr. Schubert is a professor of electrical and computer engineering at Indiana University, Indianapolis, and has served as director of the Richard G. Lugar Center for Renewable Energy since 2012. He's also CEO of Green Fortress Engineering Incorporated, working to commercialize advanced hydrogen technologies. Peter holds 43 patents in the US, plus 13 in the EU, and he has managed $5 million in research grants and has published over 120 technical works, including a textbook on asteroid mining. Peter is also the board chair of a not-for-profit that awards scholarships to students pursuing aerospace careers. So Peter, thank you for joining us tonight. And maybe we could begin with a little background. What really led you to begin pursuing research in this area?
It was the Arab oil embargo of 1973. So many of us may remember those times when there were lines for gas for the first time in American history. And I was about to get my driver's permit. And I thought, no, not on my watch. I sat in the rear facing seat of the Vista Cruiser that my dad was driving, seeing the angry faces of the people behind us waiting to get 10 gallons of gasoline. And I thought, somebody's got to do something about this. And then the next Christmas, our president, Jimmy Carter at the time, said, we have to not use Christmas lights because we're saving energy. And I thought, this has gone too far. And then I was in a church youth group, and we were in Connecticut. I grew up in Ohio. And we go into the city, into New York City, and there was a guy handing out pamphlets, and he said, nuclear fusion is the energy, the clean energy of the future, and the Russians are beating us. I'm like, all right, that's what I'm going to do. So I decided to go and be a physics major and solve nuclear fusion, the energy of the future. And after I got my bachelor's degree, I told my professor, I want to work in nuclear fusion. He goes, yeah, no. He says, go into engineering, you'll get a job, and don't worry about energy. But through my career, I always had that passion for it. And even though I worked in private industry for 25 years, 12 years ago, I was fortunate enough to be brought back into academia as a professor. And now I get to work on a whole panoply of renewable energy technologies. And I'm really excited to talk about the perspective that I've gained tonight here with you guys.
All right, well, thank you. That's an interesting background there. So can you tell us a little bit about the program that you're currently working at IUPUI at the Lugar Center there? You know, how did it get started? You know, what are some of the goals of that program? And as many of us in Indiana know, IU and Purdue are separating. How is that going to affect the program at IU, at the center?
You know, back in the early 2000s, Senator Dick Lugar of Indiana was the first senator to drive a Prius into the parking structure that the senators all use. And he got a lot of ribbing from them. And he says, hey, this is how we're going to save energy. This is promoting national security, and it's addressing climate change. And he said by the time he was finished with his Senate career in 2012, he said about a third of the cars were hybrids in the Senate parking lot. So in 2007, Indiana University approached him and said, we'd like to do something about renewable energy and have your moniker on top of it. And he says, okay, here are the couple of things that are important to me, the national security aspect, addressing climate change. And he said, and also really important, he said, university research is great, but by golly, have it turn into jobs and revenue for the state. I want to see it applied to the real world where people can see tangible benefits from that. So that was in 2007. The original director left his position when earmarks dried up in 2010. So I was the second and now probably the final director for this. And they brought me in largely because in private industry, even though I worked for bigger companies, I had side companies. So I was always trying to commercialize technology. I always had this side gig going on related to renewable energy. And I'd been publishing, even though I was not in a university, on renewable energy technologies. And they're like, that's what we're looking for. So through the 12 years I've been here, I've got the company that you mentioned that the university started, that I'm the CEO of. It's a C corporation. We've got licenses from the university to commercialize that technology. So I've got pitch decks and financial pro formas and the whole shebang to try to get investors into this technology to advance hydrogen economy starting right here in Indiana.
All right, that's very interesting. Just the last part of that was, what's going to happen with this split between IU and Purdue?
I have an advisory board that has some amazing people on it. Plus, I've got an executive committee. They keep me from going off the rails. And so I've been querying them about what should we do with the split? What's Lugar Center 2.0 look like? There's two other Lugar Centers that were in town. One was at University of Indianapolis. The other one was at Marion University. Those have since dissolved. The senator wasn't sitting senator for 11 years. He's been passed now for 5 years. So maybe that time has faded. So for the Lugar Center 2.0, I came up with these ideas to say, let's take the professors that are being squeezed out by this new Purdue IU split and make them consultants. And then we'll also work with the State Office of Energy Development and create an incubator for sustainability and renewable energy and energy efficiency. And then the people that come into the incubator, will have them be apprentices to senior people doing the consulting stuff so they can find out how business works. We can bring students in as interns. And then if we find perennial problems that normal consulting can't really address, we bring those back to the professors and say, this is a long-term, deep technical problem, go work on this. So I'm trying to figure out how to put all this together as the outcome of what happens to the Lugar Center after the two universities have so far said, meh.
No, that's interesting. Just as a little side note there, Senator Lugar was actually on the board of the Indiana Council for World Affairs a number of years ago. So he's made his mark in a lot of places. Yeah. Yeah, they don't make them like that anymore, I guess. Before we get into talking about some of the specific technologies, maybe you could help us understand some of the political realities we're facing today. I mean, is there any doubt about global warming? There still appears to be deniers out there. And why has this distrust of science seem to have kind of emerged? What is the current thinking on the scientific community about climate change?
Yeah, we're probably all familiar with the International Panel on Climate Change. That's met a number of times, and every several years they come out with a new report. And as the reports have come out in sequence, they've gotten more and more certain that there is anthropogenic or human-caused effect of climate change. That other things like the planets being out of phase or the sun getting less strong, those are the kind of things we heard back in maybe 2005. All those have shown to be true, but so much smaller than the effect that we're seeing that they're not really there. As an IPCC, they have to get sign off from every country, which means it's the most conservative possible answer they can give. And yet in their most recent ones, they're saying things like, highly likely human activity is causing climate change and things are about to get really bad. That's the conservative answer. What's probably more realistic, if you ask just the scientists that didn't have to go through the filter of their government overseers, is that things are bad, they're accelerating, and we're in for a lot of trouble unless we start making changes fast. And it looked like COVID kind of bent the needle back down. But then as soon as COVID was over, it's back again. We're now on the exact same trajectory in terms of percentage of increase of CO2 in the atmosphere as we were right before COVID. So there doesn't seem to be any indication that on a sufficiently large scale, humanity is avoiding the worst impacts of climate change.
So, and one of the other things that I'm kind of curious about is, why this anti-science bias has sort of emerged, especially in political leaders. Are they serious about this, or are they doing this for political points?
To understand that, this is a really interesting question. I've read a bunch of books on that. My favorite one is called The Merchants of Doubt by Naomi Oreskes. But starting back in the 60s, the tobacco companies knew that lung cancer was being caused by their product. And the Surgeon General knew it, but they didn't do anything about it. So the merchants of doubt concept is that the companies that benefit from the status quo will hire an academic with credentials to either publish an opinion or to write papers or to do studies that help support confusion and doubt. They're not trying to disprove that cigarettes cause cancer, but rather to say there's other things that cause it. It might be the impurities in the tobacco. So we need to maybe go to more organic tobacco, or there are other factors in people's lives. And in cancer studies, it's really hard to find the cause of it. You can find trends and cause and effect, but you can't say what caused this person's cancer. You just can't do that. We don't have the technology for that. So by sowing doubt, that meant that the public was not aware of the risks of smoking tobacco for many decades after it was pretty obvious that it really was true. That same modus of operandi is used by the companies that benefit from the current status quo in how we do energy to prevent there being a clear consensus by sowing discord, and then through the corrupting influences of Citizens versus United, they're able to make contributions to politicians who will parrot their narrative.
Yeah, that's a kind of a distressing situation. As kind of a science geek myself, I really find that very distressing. All right, maybe we can move on to some technical stuff now. So one of the things that's talked about in the article, if those of you who had a chance to read the article, is a discussion about rare earth minerals, and that seems to be a big key component in many of these new technologies that we're going to be talking about. Maybe you could just tell us a little bit about what is a rare earth material or mineral, and are there serious constraints about acquiring these?
Kind of. Most scientists or chemists for sure don't like the word rare earth because they're not rare in the sense of hard to find. Things like platinum, that's rare, but we don't call that a rare earth element. Rather, the Swiss chemists who first, or I think it was no, yeah, it was a Swedish chemist who first discovered these elements said, "Oh my gosh, we haven't seen these in isolation. They're not concentrated." So he called them rare, and earth meant mineral at the time, so the name stuck. But what it really means is dispersed. So by dispersed, what I mean is if you compare like to gold, back in the day, you could pan for gold out in the Rocky Mountains, and gold tends to accumulate with itself. There's a principle in chemistry called like likes like. And that's true for gold and many other minerals. They'll clump together. So you can find nuggets of gold in a stream. But these particular elements, they love to be connected with other things, not so much themselves. And that means that when you find them, they're scattered all over the place. So they're not rare. They're relatively abundant. They're as abundant as sulfur and copper, which are not rare, but they're hard to find concentrated ore bodies. And what that means, the consequence of that, is that in order to separate them, there's some difficult chemistry, which means expensive and it means dirty. So the extraction process of getting enough earth out of the ground and then processing it with some nasty chemicals in order to get the rare earths that you want, that in small quantities combined with other things give you some really great things in LEDs and smartphones and magnets. These things have a very devastating impact on the environment. So that means that countries that have relatively loose requirements for environmental damages, think of the outback in Australia. Think of the Gobi Desert in China. Those people have abundant sources of these minerals and sell them onto the open market. But in the United States, where it's very difficult to get permits for things that are really bad for the environment, we have those available, but we just aren't mining them in the same quantities as other global sources.
Okay, interesting. Yeah, when you hear the term, it makes it sound like there's not much of it, but it's just the dispersion issue. So, what are some of the specific technologies that you're working on right now? You know, what stage are they, or some basic research level, or some close to market?
Yeah, as a university researcher, we're supposed to look out ahead of the curve. Once something has been commercialized, then we say, not not our job. So solar panels, pretty well developed, but I do have a technology to help make them cheaper. Wind turbines, pretty well developed. They're commercially available, but we've got a researcher in the Luger Center who says, "Hey, why don't we use a hydraulic motor on the wind turbine and inside the nacelle?" So a hydraulic motor compresses a fluid, think of just water, and then if you send that to a hydraulic motor turning a turbine or turning a dynamo, then instead of doing electricity up in the nacelle, all you have is basically a pump. And then you can make the big dynamo down on the ground. So this makes the wind turbines lighter, smaller, cheaper. Now, it only makes sense if you have a whole farm of them. If you do it per individual one, it doesn't make as good economic sense. But this is a way we could make wind turbines a lot cheaper and less visually impactful in our environment. So we're trying to get that sort of stuff developed. But if we think of wind and solar, the very first thing you think of, especially live in Indiana, where you hear this litany over and over again from our elected officials and our 5 investor-owned utilities, they're intermittent. And we're the state that works. We have more manufacturing jobs per capita than any other state. And by golly, we need that power on 24 hours a day. Wind and solar don't do that. And that's the excuse that our investor-owned utilities are using to say, keep it light. We'll do a little bit, but not too much. So our response to that in the Luger Center, Ray, is to develop low-cost energy storage. Now, everybody knows about batteries. Batteries are ridiculously expensive to store energy. When we have little batteries at home, if you measure how much energy is in there compared to what you get out of the wall sockets, it's like pennies. And batteries cost dollars. They're just not very efficient. What's a better source, and the US is the leader in this, is to pump water uphill. It's a gravity battery. So if you've got 2 reservoirs and you pump water uphill when your wind and solar are going full speed, now you've got a reservoir that you can open up the penstock, let that drop down and turn a turbine, a Pelton wheel, and then that turns a dynamo, and now you make electricity. Now, you usually do that when you've got mountains. So that's all over the Pacific Northwest. They've got a bunch of it there. What do we do in Indiana, where our highest elevation is 800 feet above sea level? We go down. Indiana, especially Southeast Indiana, 12 counties down there, have the Illinois Coal Basin. And there's a bunch of abandoned coal mines with underground mine voids in the gigaliter quantities. So we can take these abandoned underground mines, which are useless. There is some environmental cleanup the first time you use it, but then you use a closed loop. We have to build a new reservoir on the surface. And now we can use these as gigantous batteries. So we can add more wind and solar, use their excess. Wind is usually at night when people don't need the power, to lift that water up, and now use it during the high point of the day at 4 o'clock, like in July 24th, when we need abundant air conditioner power for that. And this is way cheaper than batteries. It's something we can do domestically in Indiana. We can turn this into a business here that we take to Illinois, to Michigan, Ohio, Kentucky, etc. And then this is a way that we can now add more wind and solar, which are cheaper per kilowatt hour than coal or natural gas by a big margin, and provide the steady state base load power and finally address that concern about intermittency, and then be making cleaner power and also reduce people's electricity rates.
That's cool. What are some of the other battery technologies? I think I saw something called sand batteries. Um, does that ring a bell?
Well, the big ones are lithium ion, right? Those are in Tesla, those are in vehicles and stuff like that. Lithium is the lightest metal, and so that makes a pretty light battery.
Mhm.
But for large storage, I've not heard of a sand battery, but there is a saltwater battery that's getting a lot of press now, using sodium instead of lithium. Sodium's heavier than lithium, but it's way cheaper, and everybody's got sodium because it's in seawater. But there's another one using vanadium. Vanadium is kind of cheap, but not super cheap. It's used in steel, so there's a lot of it in the global market. Vanadium can be used in liquid form. And if you imagine a membrane between my two hands, you flow vanadium from one reservoir to another past this membrane, and you can exchange electrons one way or the other. So you can charge it up and you can discharge it. This is called a flow battery, or a vanadium flow battery, or VFB. And this has a lot of potential for maybe cutting the cost of the batteries in half. And the big benefit is because you're using it in vats, if you want to scale it up, you keep the same heart of the battery the same, but now you can just make the vat bigger. So there's a lot of great benefits of using vanadium batteries on the grid.
I think the thing I saw about sand batteries was you heat the sand when you have abundant sun and wind, and then you run like a heat exchanger through the sand to extract the heat later on. Must be something different though. That's all.
There's that would be really low cost, but sand doesn't move very well. It kind of tends to just sit there. So what people use instead for thermal batteries like that is liquid salt. So you say the word salt, everyone thinks of the white table salt, but there's a bunch of other salts. Salt just means a metal plus a halide, so it's chlorine or fluorine. But there are certain salts that have melting points such that you can put heat into them and they will become a liquid. And now you can move the liquid. So when you put the heat exchanger in it, you just do some gentle mixing with the liquid, and then you get really good heat exchange. So that's what's used in those sun towers in the Nevada desert, where they have all those heliostats that are putting sunlight onto it. So that means they can store that heat and then use the electricity in the evening when people come home, and that's when demand goes up on that duck curve. And now they can provide that energy back into the grid.
So from a application perspective, where are we with these technologies? Are we still doing research on them? I mean, are they ready to go?
Every new technology starts off being more expensive. So it's difficult to take a new technology and to catch up with the maturity curves of technologies like coal-fired electric power or natural gas turbines. Those things have had the benefit of being around for so long that their cost per unit energy is really low. And Americans, for the most part, are not very tolerant of paying more money for a while until new technologies will come down to that same cost level. So what that means is that it's very, very difficult to break into the market. It's difficult to find investors that will front the money because they're not sure if they're going to get their money back. So we're kind of trapped in our status quo with the need to dramatically accelerate our climate change reducing technologies. And that's one of the things that I really applaud the Congress and the Biden administration for developing the Inflation Reduction Act. In that is the largest climate mitigation effort ever done by any country anywhere in the world. And I'm glad to say that I'm a leader of a group that's won some prize money in that area, and we're trying to bring renewable energy technologies to rural communities. So I can talk about that, but that's a little bit off of our particular topic today.
Okay. So you mentioned hydrogen earlier as one of your areas that you're interested in. Could you talk a little bit about some of these hydrogen technologies and where we are with them at this point? I know Toyota has kind of been on the sidelines with respect to electric vehicles because they're moving towards hydrogen approach to vehicles.
Yeah, I think it's fascinating how the the term hydrogen economy is there. Everyone's probably heard that term. That was coined by a GM engineer in 1971. So if we think about batteries and hydrogen in the United States, those have seesawed back and forth in terms of popularity. The last time hydrogen was really popular in the US was in 2002, 2003. The Bush administration said, let's go whole hog onto that. That was largely pushed by West Virginia that said, hey, we've got coal and everybody hates coal. So what if we gasify the coal to make hydrogen? And then that's another way that we can sell our coal. So then in the Obama administration went over to batteries, and we've stayed in batteries for a while. So now we're coming back a little bit when people are like, well, batteries have taken us pretty far. But for example, taking Class 8 trucks that go over the road and have to go, 1,000 miles before they stop. Those are going to be so heavy because the batteries are so heavy that's going to pulverize our roads into dust. So companies like Nikola, Class 8 trucks that are fuel cell driven, and those need to have hydrogen. So hydrogen, if you think about the hydrogen molecule, comes in a gas as H2, but you can separate out into an individual hydrogen if you need to. One hydrogen has the weight of 1/7 of lithium. So now we're comparing batteries to hydrogen. Lithium has an atomic weight of 6.9, hydrogen is 1.008. So about a 7-to-1 difference, and they both carry a charge of 1. So if we can store hydrogen and put that into a fuel cell, we could have an electrical system that's like 7 to 10 times lower in weight than batteries. And that's the holy grail to get to that. But how do we store this stuff? So I've been working on this problem for a while, and I was actually writing a textbook, or not a textbook, a fiction book that's now available on Amazon. And I talked to somebody and they said, well, Peter, how long is this all going to take? I'm like, well, like 41 years. And they're like, who thinks that far ahead? And they said, why does it take so long? I'm like, everything always takes longer than you think. They said, well, write a book and maybe it'll happen faster. Well, it hasn't happened faster. But in the book, I was like, okay, if we had abundant energy and we wanted to use it in transportation, how would we store hydrogen? And I thought, let's use silicon, because I know silicon very well. It's used in photovoltaics, computer chips. And I thought we can make it porous and store the hydrogen on the surface. So now it's a solid state hydrogen storage, not compressed gas, not a cryogenic liquid, but something that's way cheaper. And so now I've got 4 patents on that. And that's the way, Ray, that we can put this into vehicles instead of a battery, and then run a fuel cell instead of just an electric motor.
So I mentioned Toyota is kind of the leader in the automotive industry in this. Do they have a viable vehicle yet?
They have the Toyota Mirai that was released in California. Hyundai also has the Tucson that comes in a fuel cell version. California has had a come and go study with hydrogen. At one point, they had a whole bunch of hydrogen refueling stations, which were huge, and they required a lot of electrical energy to compress the hydrogen enough to make it sense to put it into a vehicle. Then they threw all those away. Now they're in the process of building that back up again. So that's why instead of the high pressure stuff, that's why I went with this solid state approach. And then the other issue, the other side of the coin is, how do we generate our hydrogen? Right now, 99% of the hydrogen that's used in the United States is made from methane. CH4 is its chemical compound. So you take this with steam, H2O, and you heat those to a pretty high temperature, and now you get hydrogen gas that comes off, and CO2. So you get pretty cheap hydrogen, but there's a pretty enormous CO2 penalty for making hydrogen in this way. But that's how everybody does that. So we wanted to use hydrogen to make it more renewable, right? So the approach that I pursued was to use non-food biomass. So our main target is corn stover. That's the stalks, the husks, the cobs, and the leaves. So the farmer takes the cash crop, the kernel, and they sell that in the market. Now they go back and take off not all, but most of the corn stover. And then I've got 5 patents on the machine that can turn that into a gas that can be used to run a generator that continues the operation of the process and has excess electricity. And then Ray, this summer, using resources from the National Renewable Energy Lab that's part of DOE in Colorado, we figured out a way to get a hydrogen membrane separation unit that can take our gas, which is half hydrogen, separate out the hydrogen, and be able to produce that for $1 a kilogram, $1 a kilogram. With the steam reformed and methane, the wholesale price is $4 a kilogram. The retail rates are $7 to $12 a kilogram. And because ours is green, we qualify for $3 a kilogram from the Inflation Reduction Act. And I can't get investors to give me the money to help have this happen. But I'm still trying, and I haven't given up.
Right. So, in terms of the long term with hydrogen, do you think, 50 years down the road, hydrogen is going to be the go-to fuel? Or is battery technology, portable battery technology, like for cars, going to become more denser? I mean, use less battery to get the density of energy you need.
Because the hydrogen is fundamentally, significantly better, a factor of 7, that's huge. That's, 14%. That's a reduction of 86%. That's the kind of thing that it absolutely will happen that way, but it's a question of how fast. I'm sure everyone here who's watched technology, I mean, I remember watching men walk on the moon when I was 9 years old, and I thought, oh my gosh, we're going to be in Mars in just a couple more years. This is going to be so cool. I can't wait to be an astronaut. We haven't left Earth orbit in over 50 years. So things don't happen as fast. That's why I have a 41-year plan.
Now, this kind of goes back to the question of climate change. Are there things that need to happen faster than others to kind of address climate change in the short term?
Probably the most important thing is energy efficiency. For many decades, Japan has been a model of a very modern society, very technological society, but they're really careful about how they spend every watt of power that they've got. In the United States, we are focused more on the end use, and energy efficiency is not very popular. And yet it's the most important thing that we could do. So globally, probably the biggest impact would be 2 things. One is if the United States on a per capita basis could use significantly less energy of all types to live by being more energy efficient, that would be huge. The other one is that we're still having a lot of coal being burned in China and India because they're trying to grow their economies. And even though China is moving pretty quickly towards renewables, India has, and they've got great initiatives going on, but they're still burning a very large amount of coal. So we have to, what I think that has to happen is the United States has to get better at efficiency, and then we have to develop the technologies that will help everybody around the world adopt them. And then we can have a compounding beneficial effect for the environment and have everybody be able to live in a reasonable environment for all time to come.
All right. Just let me interrupt a second. If you have a question, please send it to me in the chat room. And when we'll switch over to the audience questions here in a few minutes. So if you send your questions to me in the chat room, I will kind of call on you in order, and then you can ask your question. So, okay. One of the things that I'm kind of curious about is the role of government versus private sector in researching and bringing new energy technologies to the marketplace. Um, I hear politicians saying, "Well, we shouldn't interfere in the marketplace. The market should determine what technologies are actually implemented, and it's not government's role to kind of pick winners and losers." How do you feel about that? And what is the role of government then in kind of getting these new technologies off the ground and in place?
Yeah, if we look historically at where research and development was done, 50 years ago, most corporations that were in the technology field would spend 7% of their revenues on research and development. Bell Labs, of course, is the obvious example. But the federal government also did a lot of fundamental research. So, like in my office now, I've got these huge books of data on material properties and I mean, there was so much great work done for a long period of time that it provided the background information that spurred a tremendous amount of technological development. And there were corporations that were actively paying people. Famously, 3M used to say, spend 15% of your time doing something that's not on your job description. But fewer and fewer companies do that. And more our elected officials want to see the results, just like Senator Lugar said. There's no problem with that, but it means that the research is becoming more applied, which means that we're getting the benefits, which is good, but we're not spending in my opinion, it's not quite balanced with the pipeline of technologies that we might not even be able to anticipate what their applications are. So to get to your question specifically, elected officials, at least in the United States, tend not to be technically oriented. The 118th Congress had like 5 people who had technical degrees. If we compare that to other countries, China is a great example. Almost everybody on their board is an engineer. But we don't value engineers in the same way. We have a lot of lawyers. They're not as technical. And many of the people in the House of Representatives don't have technical experts on staff. And so they're not really in a good position to pick winners and losers. So when they pick winners and losers, when they pick a technology, it's often for motivations like I'm helping my constituents or I'm bringing jobs into my area. And that's totally what they're all about. But I think that the United States has not yet figured out how to get enough diversity in new technologies and give them enough funding and enough runway to be able to take off. There's a strong tendency for in each administration to let's find something that can help solve pain points right now so that the current president can claim credit for it. And then we're not thinking beyond every 4 years.
Well, I drive down 65 south of Indianapolis, and I see all these new warehouses, and I guess up 65 towards Chicago as well. And there's acres of rooftops that don't have solar panels. Why is that? What's the private sector thinking about with respect to why they're not taking advantage of this space that they have?
Our state had pretty generous net metering laws. We didn't have a renewable portfolio standard like many other states did, but for a while it was pretty attractive for people to put solar on their rooftops. Same thing with businesses. It was pretty attractive. Then in December 2022, that had a sunset. Now the amount of net metering they offer, it's not zero. Some states are at zero, but it's so low that it doesn't pencil out, that you have to be in business for 20 years or more before you're going to get everything paid back. So the state has made it so that it's really not economical to put things on your roof. And those warehouses, they're absolutely focused on the bottom line. They have to keep everything as cheap as possible. So because it doesn't pencil out to do solar, they don't. Furthermore, our state building codes are really light compared to others like Illinois I'm more familiar with. Their building codes are pretty strict. They have Chicago there, and fire is a really big issue and so forth. So they have a lot of cool things in there. In Indiana, they're like pretty much everything is okay. And what that means is that we're stimulating people to build in Indiana, but we're not taking advantage of opportunities like you talked about, where we could put solar on those rooftops instead of taking it up from farmland that it has to happen instead, and we could get a twofer. We haven't figured that out here in Indiana.
Interesting. So, I mean, Duke is a big player here in the state. You know, what is their long-term objective, do you think, with respect to renewable energies? Are they actively blocking these things, or are they actively trying to create new opportunities?
I don't know enough to address those directly, but as the director of the Lugar Center, I get some exposure to that. There was a Senate Bill 309 about 3 or 4 years ago, and I went in there to talk about the issue of, if there's a bunch of solar on people's roofs, does that mean that they're using up grid services but not paying for it? And so when I said, yeah, I'll be a speaker, they said, are you for or against? I'm neutral. They go, we don't have a category for that. I'm like, I'm a university professor. I'm not allowed to advocate. I just want to give information so that people will understand the technical issues involved. They go, well, we'll put you last. So I never got to speak. But what I hear from individuals and individual companies is they're very open to renewables. If we look at the smaller companies like Hoosier Energy and Wabash, those people are doing a lot of great things in coal bed methane, anaerobic digesters, solar farms. They're doing a lot of stuff like that. AES, it used to be IPL. We've got a ton of solar here in the city of Indianapolis. But if you look at their organization, where all the investor-owned utilities get together, they're a little bit more conservative than that and not as progressive, because they're protective of their business model.
Interesting. We have a question here from Pankaj Sharma. Pankaj, you want to ask your question? I think you actually have two, don't you? So.
Hi, Peter. How are you?
Hi, Pankaj. Good to hear from you.
Nice to see you after a long time. I hope that you are doing well.
Thank you.
Yeah. Two questions. You mentioned something about your interest in hydrogen, and hydrogen, there's some issues related to the storage in terms of safety, etc. So I'd like you to comment about this. And also, in order to produce hydrogen, you need to split hydrogen from the oxygen. So there's some energy needs to be invested. So that's another challenge. So I'd like you to comment on that hydrogen aspect. And second thing, I do not know if you have been involved in anything discussion about having nuclear energy as a portfolio of Indiana technology, and small modular reactor. There are a lot of discussion at Purdue University has been going on, series of speakers talking about the possibility of having nuclear energy in the state of Indiana, for that will cut down the greenhouse gas emission and so on. So if you have any comments, I'd like to hear from you, Peter.
Okay. Yeah, thanks. Those are great questions. All right. Number one, hydrogen storage safety. If we think about compressed gas, that is 700 atmospheres. So it takes a ridiculously high pressure to keep hydrogen small enough to fit into the car in meaningful quantities. If those were to rupture, they would explode just from mechanical energy. Now, they've designed them so that they should not rupture. They've shown tests where they bounce these down the road at 60 miles an hour and they don't explode. But they haven't done this in large enough quantities to find out how they operate in real crashes. So that's a concern. If we also look at cryogenic storage, the BMW had a Series 7 cryogenic storage. Those are going to evaporate very quickly. So that's a concern. But what would happen if they crashed and now that liquid hydrogen ran out? People could get burns from it before it evaporates. Not too bad of a thing. But with hydrogen, you usually worry about fire. And with the technology that I have the 4 patents on, 3 of which are owned by Indiana University, 1 that's owned by my company, we're storing that in silicon. So silicon is in your fingernails and your hair and your skin. It's earth abundant material. And because we're storing it in a solid state, it's not flammable. It might support a small flame, but it's not going to like burst into flames. You're not going to get a sudden release of energy. And it's not like a metal hydride that gets super hot when you recharge it with hydrogen. So I believe that the technology I've got for hydrogen storage is inherently safe. That's number one. Number two, splitting hydrogen. Yeah, I totally understand that electrolysis is the way that almost everybody is pursuing to make green hydrogen. And I say, that's a dumb idea. The reason is that the amount of energy it takes to split the water molecule is huge. So you'll never get it to the point where it's that green. You're trying to make hydrogen as an energy carrier, but if you're putting a bunch of energy into it, that's stupid, in my opinion. So I've done a different approach. So let's think about lignocellulosic material. That's a $64 word that just means woody biomass. So think of wood chips or sawdust. So wood chips, sawdust, crop waste, they're about 30% carbon, 30% oxygen, 5% hydrogen, and then some other stuff. If we can gasify that and take it up to a temperature of 950 degrees C, then all of those complex organic molecules break down into simpler components, and we end up with a gas. And the gas is H2, hydrogen, and CO, carbon monoxide. You don't want to breathe it, of course, but we're using this and burning it in a spark-ignited, reciprocating internal combustion engine, a natural gas engine, and that's turning a generator. The generator provides electricity that heats the next round of biomass coming in, so there's no flame, and so there's no danger of risk. We're also at room atmospheric pressure, and this is energy self-sufficient. So that's how we get to that ridiculously low price of $1 per kilogram of green hydrogen. On number three, for nuclear energy, small modular reactors, they're very sexy. And I know that the General Assembly in Indiana just loves them. We've had a love-hate relationship with nuclear since 1984. And so I think they're a reasonably good idea. However, we still have this problem of uranium reactors running uranium-235 that make byproducts that stay hot and dangerous to humans for 300,000 years. Nobody can anticipate how we can store that stuff. Yucca Mountain never got built. There is no solution for how we get rid of our nuclear waste. Countries like Japan, I've heard anecdotally, will ship their nuclear waste to countries in sub-Saharan Africa that will be able to just throw it down a hole and not worry about it. It's a terrible mess that we've got, and there's an easy answer, and all it takes is political will, and that is thorium. Thorium is close to uranium in weight, but it's 3 times more abundant, and thorium can be transmuted into uranium-233, which is different than 235 that's natural. So with an existing reactor, we use the neutron flux to irradiate the thorium. That transmutes into uranium-233, and even though it's only got 2 less neutrons than the uranium we've been using, the byproducts, as it breaks down and releases its fission energy, have dangerous byproducts that go safe after 80 years. 80 years we can figure out. So if the United States would go back to what they did in 1970, and what is currently being researched in India, where they're looking at thorium reactors, we would have a solution where we can not only get the benefits of low carbon energy from nuclear, but we would also have where we'd solve the problem of nuclear waste.
Yeah, the India has a lot of these thorium deposits. They call it like monazite.
Monazite, yep.
Monazite. So probably, but I'm surprised that other countries have not really pursued it, because probably that they don't have this monazite or that much available to them, and so probably, yeah. Okay, thank you, Peter.
Okay, thank you, Pankaj.
Yeah.
Claire Collins, you want to ask a question?
Yeah. Well, first I have a comment. I got my driver's license in 1966, and my father was a petroleum geologist, and he said then, we're going to run out of oil someday. But and in 1977, when Jimmy Carter became president, there was a coal miner strike, so that just complicated everything. But anyway, my question was, are you talking about the car carrying its own hydrogen, or will there be a need for charging stations?
Definitely carry its own, but you bring up another interesting topic, which is wouldn't it be great if we didn't have to carry any fuel? And especially think about aviation. Right now, transportation of all types is about 25% of our carbon footprint as a global society. But trying to decarbonize the atmosphere is really difficult. Here's the problem with battery planes. Stupid idea, because when you have jet fuel, you take off and you're heavily loaded. But once you get up in the sky, you're burning your fuel. You're much lighter when you land, and that makes it pretty safe. With batteries, you move electrons from one side to the other, but you don't lose any weight. So not only are they way heavier than jet fuel, but you're landing with a plane that's way heavier than you're used to landing, but not very safe. Batteries, no good for airplanes. Hydrogen, much better. Still not as good as jet fuel. Hard to beat jet fuel, but we can get about within a factor of 2. But for things like air taxis, so if you think about Orange County in California, or Aurora in Chicago area, places where the traffic congestion is so terrible, people are like, we need air taxis. What happened to the Jetsons? So the problem with getting air taxis enough energy is that the FAA says you have to keep 30 minutes of reserve fuel on board so you can land safely. And everybody's like, we don't know how to solve that. So I've been working with a number of people on wireless power transfer. So we call it WPT for short. It's power beaming, but as soon as you say power beaming, people are like, oh, you mean a death ray? We're like, no, we're using low density radio waves that won't hurt anybody. They won't burn birds. They won't make bugs go away. This will pass through any kind of living matter, because we use a frequency that's specifically designed for that. With this approach, we can take what's called a phased array antenna and be able to beam radio waves through space and direct them to a flying car, and then be able to provide it with the energy it needs to stay aloft. That still has to carry that 30 minutes by law, but all the rest of it, we can have it pass over a number of these stations. We can do the same thing, Clarice, with highways, where electric vehicles, we can charge them up by having this phased array antenna follow them as they go past. We have a patch on the side of the car that picks up that energy, so a car can gather its own energy as it goes and doesn't have to stop to recharge and refuel.
Wow, everybody will want to have a hydrogen car. And I drive a 2006 Honda Civic that never gives me any trouble. So why trade it in yet? But think of all the cars that are going to be in junkyards. Well, you'll want to recycle them and use their metals for things, I guess. Thank you.
Thanks, Claire. David and Lorraine, I'm not sure which of you was asking the question here, but.
Well, our question is, what can you comment about the technology of generating hydrogen on demand based on water and aluminum as a catalyst? That there's a company here in Indianapolis that called Dalco that is testing this G in the Carmel's fleet. Do you have any information to share on that?
Yeah, I can summarize what Kurt Kaler is working on. He has a technology he's licensed from Purdue, developed by Woodward, the chemist who had an eye patch, who found out that when you take aluminum metal and mix it with gallium, that when you put water on it, normally aluminum will form a skin of aluminum oxide, which is the same stuff as sapphire, but with a little bit of gallium in it, it prevents that from forming. And so the aluminum turns into aluminum hydroxide. When that happens, hydrogen gas is released. So the approach that Algalco has been doing is to put a tank in the back of a fleet vehicle and be able to put a drip of water onto a bed of this aluminum gallium mix and then it makes hydrogen. They mix in with the gasoline, and now you get a boost of your fuel, an extension of your range, and the hydrogen helps it burn cleaner, so your exhaust is better. So the kind of approach they have is for when you have a vehicle that goes out and comes back to the same location. For your home, maybe this doesn't make sense, because in order to reprocess the aluminum hydroxide back into pure aluminum and gallium requires a process that's very energy intensive, and you have to do it at a large scale facility. So he's been in discussions with, for example, New York City. Could they put it into taxis or city vehicles? So that's where they've got a lot of interest in that. So for fleet vehicles, that might make sense. The approach that I'm using, where we can use lignocellulosic or woody waste materials, you can do that at any site, at an office building, at a factory, at a farm, at a warehouse. They can take their woody materials and even some plastics, turn that into hydrogen on site, on demand, store it with my solid state storage material based on silicon, which is already part of our body, so it's non-toxic, and use that for forklift trucks, use that for vehicles, use that for fleet vehicles, etc. But because it doesn't need to have reprocessing to refill it, you just put more hydrogen into it. Now it's available for everybody, not just for fleets.
Okay, thank you, Lorraine. I'm just curious, this is the Indiana Council on World Affairs. What countries are kind of leading the way now? Is the United States leading the way in some of these technologies, or other countries doing a better job than we are in terms of developing these technologies?
If you look at what they say, the EU is very bullish on hydrogen. In March of last year, I became an E-resident of Estonia and formed a company over there, a branch of my US company, and applied for 1, 2, 3 different EU grant proposals. And oh my gosh, they find the smallest little mistake you make and say, nope, you're out. I was like, oh my gosh. I thought it was hard to get grant money in the United States, but it's way harder in Europe. And I validated this with a bunch of other people. They're like, oh yeah, if you're not super polished, if you have any spelling mistake, any inconsistency in your budget, if you didn't address and tick off every little thing, they instantly throw you out and don't give you any kind of review. It's really hard to get money in the EU. It's very, very competitive. But that would be a market where if you could crack into it, would be really great. Japan has been really hip on hydrogen for a long time. They wanted to have the Olympics, the Olympic Village from a couple of years back. They made hydrogen vehicles that were taking the athletes back and forth. The village was run mostly on hydrogen. So I tried to have some technology available for that with Sumitomo. We weren't quite ready for that. And they also thought, we've got an advanced nuclear fleet, and until Fukushima, they thought they could go get nuclear hydrogen, which is a really smart way to get hydrogen as well, also low carbon. But that's stalled somewhat because of Fukushima and because hydrogen is just very difficult to work with. So who's going to lead this charge? I don't know. I think the US is really in a position to be the leader, but we need to be able to move forward a little bit more quickly. We have so many people who are just kind of pulling back from anything that's going to help the environment for the future and focus on how can we help ourselves right now. We need to think, like as Mary Poppins said, some people can't think past the end of their noses.
One topic we didn't talk about yet was geoengineering. I know the author of our article was a little skeptical about some geoengineering issues. What is your opinion and take on geoengineering as a technique for addressing climate issues?
I was up at Purdue at their rocket club, had a bunch of NASA engineers. They invited me there as well. And they said, one of the questions from the audience was, what about this idea that NASA has been looking into of putting mirrors between the sun and the earth, where they could adjust them? It'd take like 1 million mirrors, but they could adjust how much sunlight we get, and we could use that to moderate the temperature. and all the NASA people, because this was promoted by General Pete Worden, who was the director of Ames National Lab. He's a very high up guy in NASA at the time. They were all like, it's an interesting idea, very intriguing, maybe, all kind of equivocated. And they finally got to me and they said, Dr. Schubert, what do you think about this idea? I said, it's a Band-Aid. The students all laughed and they're like, what do you mean by that? I'm like, well, we're taught in system engineering, you go for the root cause of the problem, which is the carbon we're emitting. We solve that problem. Then we don't have to do these geoengineering solutions, which you never know what kind of a gazillion different effects those are going to have. We don't yet know how to model our climate on our planet, even though we have huge supercomputers working on this. How can you say that a simple fix isn't going to cause some other thing to just go wonky, out of control? So I think that's a cautionary principle. We should really focus on, how do we solve the root cause of the problem, and then it goes away.
So you're not big on geoengineering then?
I think it's a solution of last resort. One example is like when Pinatubo erupted some number of years ago, the Earth cooled down for 2 years. And it's mostly because of the sulfur oxides that were put into the atmosphere. Those are really effective at blocking the sun's rays. So people talk about, well, can we deliberately cause a volcano to blow? Oh my gosh, what a dumb idea. But that's the kind of thing where that would work if we get into like some dire trouble, maybe in 15 or 20 years, if we haven't turned that curve downward of our increase in carbon emissions, we may be forced to do those sort of things. But by golly, Ray, I hope we don't let it get to that point.
Okay. Ann Kolb has a question, and then Mel Miller will be next after her. So Ann?
Hi, thanks so much. I'm going back to the discussion about grants in the EU, and I was just curious if you have if you've done any work with the embassy grants in other countries. So a lot of those, I think, are partnerships between the United States and countries, and there are submissions where they specifically highlight areas that they want to partner and get more information about. And so currently the list, which I think can be accessed fairly easily, is there's a lot on climate and climate change and climate crisis ideas and exchanges. And so if that maybe isn't one that's been explored, maybe that's something that could help kind of get a foot in the door for some of those technologies.
Yeah, those are great points. And I think that is in my future, where the technologies that I'm developing are, they're not yet commercial. Like the hydrogen technology, biomass to hydrogen, we built 3 of those units, but they're all at relatively small scale. So most people call me back when you've got something that's commercial, badge, serial number on it, unit of sale, warranty on it, etc. So my technologies aren't to that point yet. And what I found is that I've got a lot of focus on sub-Saharan Africa, because I think there's a really huge impact we can make in rural remote villages, which are currently sending out their girls to gather firewood to burn to make rice and beans. So the girls aren't getting education, and the process of burning things to make food is very inefficient, and it's usually done in a domicile. So the mothers and babes in arms are getting lung distress. So if we have a gasifier for such a village, they need to use like 67% less of that material. They can provide electricity, so they can have education, entertainment, and light industry. We can also provide the hydrogen that they need. With dry material, we can make biochar that'll reverse the process of desertification, and then send, really remediate at the same time that we're helping them enter the global market. But places like USAID and the Shell Foundation, they're like, well, how many units have you already made? I'm like, well, just a couple. And they're like, no, we need something that is a known quantity, an item of commerce, and then we're ready to go. And that's the challenge I found in Pacific Island nations. I got great solutions for them. The Great Pacific Garbage Patch, I can solve that kind of problem, but I need to have a commercial unit first. And that requires that you've got a relatively affluent society. That's why I've been focusing on the United States and then also on Germany, France, Poland, that part of Europe as being early adopters. And then once we get to large enough scales, we can come down that robustness curve, get the cost down low enough, get the robustness high enough that then we can go and solve those problems in the places that need it the most.
Are partnerships feasible? Does it make it more complicated? Just curious about just any partnership, I guess.
Yeah, we're working with a company called Best in Austria that has been doing testing of gasifiers. And so without seeking money from the EU, we're working with them to see if they can take one of the machines I've got that's currently in storage, operate that on their facility, do the characterization testing, help us work together in a partnership to design a commercial unit, and then start selling those in Europe. And then finding, for example, vendors that can do subsystems that we then assemble and then sell through distributorships. And then I can get loan guarantees to bootstrap that kind of process. So that same business model, we've also got a group that's in Oregon, and they do hemp processing where they use a supercritical CO2. And then once they get the volatiles out of it, their cash crop, then we can take their dry materials and make a biochar that can be used, sold like for $300 a ton to make soil more productive. So those are two examples of partnerships that we're actively pursuing to try to get to that point where we have that commercial unit, and then go back to your first point about, working with the embassies and the Department of State.
Oh, great. It sounds like it's win-win on all sides.
All right, thanks, Ian. Mel, want to go ahead?
Yes, this is a real personal question. I have two cars now that are both hybrids, looking to upgrade. I just wondered what our speaker drives and how is it powered?
I have a Honda Clarity. They made those for 4 years. When I went back to get a new one, they said, sorry, not enough people liked them, but it has a 47-mile electric range. It's got an itty bitty engine in it, and it's got like a 200-mile gas range. So for what I do, like commuting from Carmel down to downtown Indianapolis, I can get almost all of that commute on all electric. When I go visit grandkids in Colorado, Illinois, North Carolina, then I have to stop and refill with gas. And I have to do that more often than most cars because, it's really designed for that in-between sort of thing. But still, I don't have any worry about range anxiety with it. And I absolutely love this car.
Okay, that's kind of what I'm looking at as a plug-in hybrid. Seems to me the best of both worlds right now. Okay, thank you very much.
Sure.
I'm going to put my 2 cents in there, Mel. I have an all-electric car that I've had for a year and a half now, and I've taken it on a few road trips up to Michigan. I have to say that Indiana, southern Michigan are kind of charging deserts. So, if you're thinking of a car that you're going to take a lot of long trips with, probably all electric may be not
Too early.
Yeah. But if you're going to stay primarily in Indiana, all electric works fine too. So,
Okay, thank you.
anyhow, that's my 2 cents too on that. I think Pankaj had another question for you.
Hi, Peter. You mentioned about use of silicon for hydrogen storage. Can you tell a little bit more? Because I'm more familiar with the use of calcium and magnesium for hydrogen storage, but silicon is something new. Is something published there? Does it store, like silicon is like a hard material? How do you store silicon, hydrogen into the silicon crystal, silicon lattice?
You're probably familiar with using porous silicon as an anode in a lithium-ion battery.
Oh, okay. So, okay.
It's not the same.
Ah.
It's not the same, but the problem with silicon, lithium, compounds is the silicon will swell.
Oh,
So
yes, 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 yes.
even though silicon would have a really high capacity, it would like triple the capacity of batteries,
Yeah.
people cannot solve the problem of it swelling and then cracking.
Yeah.
In that application, silicon is not yet making it. What
Okay.
we're doing is with hydrogen, when silicon combines with hydrogen, instead of lithium breaking it apart, hydrogen's like, I'm happy just resting on the surface. So
Okay.
here's the number. Remember this number, 800 meters squared per gram. That's not quite as high as activated charcoal, but it's higher than almost everything else. The pore mouth on porous silicon is 3.5 nanometers. That means that we get a ridiculously high surface area, and the hydrogen can fill up all those interior surfaces. If you think about a coin, a nickel coin, that's 5 grams. That would have the same surface area as 10 tennis courts. And every single atom on that would have 1 or 2 hydrogens. So from a media standpoint, we can get up to 7.6% storage. Not a great number, but not too bad. But because we don't have to go to high pressures, we can put this in an aluminum vessel. And then at that system level with the container, the electronics, the brackets, and the valves, we get 5.8% by weight hydrogen. Sounds like a low number, but compared to everything else, it's equal to compressed gas, it's equal to cryogenic liquid, but it's 3 times cheaper, and it's just as light, and it's more convenient because you don't have to put all that energy into either high pressure gas or low temperature liquids. So we bypass all the shortcomings of existing hydrogen storage using silicon because of the unique properties that the energy between storage and unstorage is almost equal. There's only an energy barrier in between it. So if we get over that energy barrier, now we've got a stable storage that's safe.
Is it at room temperature this thing happens? Hydrogen gets into silicon, or how does it get released? By raising the temperature, or you suck it out?
No, you guessed correctly in the first time.
Or you have to send me some paper, published paper, something like, if that's okay. I can send you separate email, or you might have my email address, sharma@purdue.edu.
Your business card is on the top of my list. You're one of my favorite people, Pankash. I will send you some materials, no problem.
That will be terrific. Thank you so much, Peter. I really appreciate it.
All right.
Thank you, Pankaj.
Thank you.
So another kind of big picture question. The UN has this Climate Action 100 Plus project to try and get global investors to put climate change on the agenda for their investments. Are you familiar with this project at all?
Yeah, they've got 3 pillars in this 100 plus approach. One is to build discourse. How do we get people to talk about this and make it a part of what you think about so you're aware of it? The second part is to celebrate people and to make sure that the people who are trying to solve this, you're giving them encouragement to pursue it. And then also the third one is grassroots programs. We can't always count on the large corporations of the world to solve the problems of the world because they're making money off the way things got to be that problem. Like Einstein said, you can't solve a problem with the same kind of thinking that got you the problem in the first place. So this grassroots approach is how we can reach people to say, hey, this is really great. And that's exactly what this Great Decisions program is all about, is to build a discourse. We're having a discourse right now. We're celebrating people. Right now, it's all about me and the cool things that I've got going on, and I appreciate that. And then we're doing grassroots programs. So in addition to our hydrogen storage, our hydrogen generation, our storage of energy in abandoned coal mines, and also the space solar power that we haven't talked about yet, Ray. These are things that we're actively working on to be able to start to solve these huge problems facing our society, trying to get them to the point where they're economical, so they'll get past the barriers of people who can't see past their end of their nose, and they're scalable, so they'll reach the sort of size we need to make a dent in the impact we're having on our environment.
So this Climate Action Project just recently number of US banks have pulled out of this. Is this short-sightedness, or is this political positioning, or do you have any idea about what's going on there?
My understanding is that central banks have a very narrow focus. They're not elected officials. They're not generally beholden to the legislature, although they might be in terms of law. The legislators don't know what they're doing, what the bankers are doing. The bankers have a very narrow focus: protect the currency and the economy in my country. So anything that helps people broadly is going to be outside of their purview. And they might say, I understand what you guys are after, but that's not what I'm here to do. I'm here to protect my country's currency. And I think that kind of short-sightedness and myopia is something that's baked into our current system. And perhaps the only way out of that is to make laws where people say, think outside our borders. Yes, we have to protect ourselves, but if somebody doesn't take a step to having banks address climate issues by investing in things that have a long-term view on helping the biosphere and supporting the economy, if we're not all doing that together, if we're all still competing against each other, we'll never break free from the status quo.
All right. So one last question for you then, as you look to the future, what are some of the technologies that still need a lot of work, but will be the real game changers? Is it fusion, space-based power? You mentioned that.
So this is a talk I gave at a conference about a year ago on solving all the world's energy problems for once and forever. And this is the basic concept. For cities and industrial parks, we need baseload power. This top left graph is a large scale, kilometer scale solar power satellite that gathers sunlight in space, converts that to radio waves, the same ones that I was talking about for the cars, and then beams us down to receiving antennas on the Earth, and then provides that into the grid so that cities have around the clock solar power with no carbon from generation. This is the lignocellulosic material, and this is how we can address the energy issues for rural remote villages. This is a concept car in the bottom center on how we can store the hydrogen in silicon. And one of the cool things is when we take corn stover and turn that into hydrogen gas, there's minerals in this corn stover, about 5% by weight, and it's mostly silicon. So I don't go into the details, but we have a way to be able to process that mineral waste to make the silicon needed to make the hydrogen storage over here. So that makes it so cheap that we can make this like 100 times cheaper than a battery. The space solar power, because it's 100% of the power 100% of the time, at night when people don't need the power as much, we can use that to make electricity into hydrogen from electrolysis. I know I dissed that earlier, but this is where we can use excess power to make hydrogen and store that into our transportation fleet. So with this overall approach of the three areas of technology that I'm developing and the synergies between them, we can achieve a goal of having everybody on the planet, or at least nearly everybody, to be nearly carbon free for forever. And that's what I'm after. That's my passion on developing these technologies, and especially in space solar power, putting all that mass in orbit. I've got 3 patents on how to use moon rocks. The moon is 21% silicon. We can turn that into solar panels on the moon and provide all this mass up into orbit around the Earth and beam that power in there. And there's so much more that can go on with that. So that's the kind of long-term thinking I've got in this 41-year plan. I've got until 2043, February 15th. I told my kids when they were little, they said, "Daddy, you're ever going to die?" I'm like, "No, not till I'm 82. I'll get hit by a meteorite." So I now know the exact date of that. So that's why I have the 41-year plan. I've got about 18 years left on it to make all this come to bear. So if any of you guys have any way to help me out, please do. Contact me through Ray, and I'd love to hear your ideas and suggestions and connections.
All right, well, Peter, thank you so much. This was a wonderful presentation. It was, I think the expanse of ideas from, from leftover organic materials to being in space is quite a range. So really appreciate you taking the time with us tonight, and we look forward to maybe working with you again. So
My
with that,
pleasure. And thank you everyone for
Well,
your great questions.
Yeah, I actually have got 3 quick questions. What was the name of your car again?
Clarity.
Clarity. It's a Honda Clarity?
Yeah, they don't make them anymore. Boo-hoo.
I want to see what it looks like. And my second comment is, are you seeking help with what you're doing, or seeking help to help you live another 18 years so you can get to year 41?
Mostly I need money from investors. And,
Yeah.
Indiana is not the place to ask for
Well,
that.
that was Peter, that was a tongue in cheek, because I'm not sure what we can do there. Eat your fruits and vegetables, Peter. Let's keep
I'm a
eating your fruits
vegetarian and have been for 34 years. So
Well-
I would encourage everyone to be vegan. I want to stay healthy until that point, and that's part of my plan.
Well, I'm a near vegetarian for that very reason.
Good for you.
Yeah. I guess,
Could I ask a question?
yes,
kind of-
Linda, yes.
What kind of financing are you talking about over the next 18 years of needing?
Seed tranche $340,000. Round A 3.4 million. Round B 11.2 million. That would be about 36 months out. At that point, I go organic and can fund my own growth.
Great. Okay.
Check
Thank you.
out
I'd like to look
Green Fortress.
into helping you with that. Thank you.
Thank you so much. I appreciate that, Linda.
There you go. I guess my question, Peter, is, in my teaching global studies, politics always intervenes its head intrusively. And then when you take a look at, this was a very upbeat program. We've talked a lot about climate change, and each year we always seem to have a program on climate change. There's a bit of doom and gloom sometimes with it, because it really deals, like with my speaker coming on Thursday, the young man with 0 hour. It's always this, like, God, we're at the 0 hour, and you're offering a big element of hope. You're offering, and it's exciting. It's very exciting. I envy you for the work that you're doing, because you get to wake up every day thinking, okay, what do I have to get accomplished today to make this happen? How much does politics muck this up? Or maybe it doesn't.
Okay, politics. I have a new textbook coming out in another couple months, and it's on a form of government that is corruption resistant. I don't think with our current system of government in the United States that we have the ability to be nimble enough to solve the climate crisis. I think we're going to, Winston Churchill said this about Americans. He said that you can always count on Americans to do the right thing after they've tried everything else. So that's what I'm waiting on, Betty, is I'm developing all these technologies and publishing them and teaching students about it and leaving a trail of breadcrumbs so that when the United States finally collectively wakes up and says, oh my gosh, we got to do something about this. Here's $100 billion. Who do we call? They're going to say, Dr. Schubert, are you ready to go? I'm like, I've been waiting for your call.
Yeah. Well, I can see you're also an idealist, and I see absolutely nothing wrong with that. Well, we were talking earlier. I was saying, for those of you still with us, that in teaching global studies, I'm finding that my students are, of course, I'm the generation that didn't trust anybody over 30, so I really cannot talk. And but they're pretty, I want to say, cynical, and they're also very distrustful of the government. And we're doing a lot of talking right now about things such as aid, and they see it as a lot of neo-colonialism. And we're going to be talking about NATO soon, and it's concerning because, we got to believe in something. There's no perfect world, so we can't hang our hat on a perfect world, because that's never going to happen. But I'm not sure how idealistic they are, because it really takes a healthy dose of idealism I think, to wake up and just really forge through. What prevents you from being a vegan?
But I started off as a vegetarian, and then I had my cholesterol checked, and they said still in the moderate risk category. I'm like, okay, I got to go all the way. So I've been a vegan since 1989.
Oh my gosh. So you are a vegan. Okay. So has that lowered your cholesterol?
Oh yeah,
Oh,
I
Yes, there
probably
you
would
go.
have had a heart attack by now if I hadn't been a vegan, according to my doctor.
really? Oh, Ray, did you?
I was going to stop the recording. It's getting a little personal here, so.